Alright, we are starting chapter 13, which um, deals with probability and statistics or data analysis. First off, in section 1, we are going to focus on probabilities and odds. Now, there are three terms that are here on the PowerPoint that I want you to keep in mind. They are outcome, event, and sample space. Outcome are the possible results of an experiment, and the event is the actual outcome or collection of outcomes, and sample space is the set of all outcomes. And if you look, the collection of outcomes and this set of all outcomes are pretty much the same thing. So if I look at incorporating these terms, let's look at example 1. It says I have 2 bags containing colored balls. The first one has orange balls numbered 1 through 8, and the second one has red balls numbered 1 through 3. They want to know how many possible outcomes are in the sample space if I were to, say, take that bag and grab one color ball from each bag. How many possible results could I actually have in our sample space? And there's 2 ways to write it. So first off, I'm going to give you like a little bit of a drawing. So here's bag number 1, and here I don't have an orange pen, so here's orange ball 1, 2, 3, 4, 5, 6, 7, and 8. Now this is bag number 2, and they have red balls numbers 1, 2, and 3. Okay? So there are 2 different ways you can write this sample space, one of which is a T-chart. And if you make it like this, on the left side here it deals with the orange balls selected, and this one deals with the red balls selected. So I have an opportunity of, in that first bag, of selecting either the 1, 2, 3, 4, 5, 6, 7, or 8 color orange ball. Those are the possibilities of me selecting. Once I select an orange ball, then I go into the second bag and grab a red one. And that one, so say, for example, say I grab the orange number 1 ball. Now when I go into the second bag, I could either grab a red 1, 2, or 3. And that comes out to be the same thing for all 8 choices. So I could either get a 1, 2, or 3, 1, 2, or 3, 1, 2, or 3, and so on and so forth, going all the way down. And if I were to count how many different combinations or possible outcomes, I would have 24 different ways, or 24 different possible sample spaces. You could also write it like this. You could also write it like, well, I could select an orange ball and orange ball 1, red ball 1, orange ball 1, red ball 2, orange ball 1, red ball 3. Then you could go orange ball 2, red ball 1, orange ball 2, red ball 2, and orange ball 2, red ball 3. And you do that all the way down to up to the orange ball 8. You'd still get 24 possible ways in your sample set. other terms that I want you to know and are very useful, especially when you start getting into more advanced math, if you plan on taking stats in high school or even in college. The definition of probability. Probability is the measure or likelihood an event will occur. It says numbers between 0 and 1, so it means that it's a ratio or you get a percentage. And if you look here on my left, you see, or right, I'm sorry, you have 0, 0.25, 0.5, 0.75, and 1. Those are the different probabilities of event. And like having a 0% chances means that it's impossible. If you got like 0.25 chance, it's very unlikely. 50-50 means that it's equally likely to happen or not happen. 7.75 is likely, and then 100% is certain. Um, Something that would be impossible or 0%, like if I went back to this example, it would be a 0% chance of me picking a red ball with the number 4 on it. Since there is no number 4, I have a 0% chance of grabbing it. 50-50 would be like flipping a coin, heads or tails. It's either going to be heads, it's either going to be tails, 50-50 chance. 100%, which means it's certainly going to happen. So say like I go into this second bag of red balls and I say I'm going to select a red ball. Well, if there's only red balls in there, of course, it's going to be a 100% chance. And then probability is broken up into two categories, one of which is theoretical probability and experimental probability. Theoretical probability is basically it's testing what's going to happen. And then experimental probability is taking the data and then showing what actually happened. If you remember in class, we did the numbered cube activity where we rolled our cube to see which numbers we get because it was numbered 1 through 6. We did that 20 times and we collected data on how many times we rolled a 1 or a 2 or a 3, 4, 5, or 6. And then those recordings were then data, and that was under the experimental probability. Now, the theoretical probability of us rolling either 1 through 6 was, again, 1 out of 6, which is roughly 17% there. So you have a 17% chance of rolling any of those numbers because there's 6 sides and you have one shot at getting either of those numbers. And by looking at the data, you can conclude that even after 20 rolls, you could see that many times it's very close to the theoretical probability. And if you look here, I have the difference between theoretical and experimental probability. Again, this theoretical probability is what should happen after testing. Like when we rolled our cube, it should have been roughly 17%. And then we had the experimental and what actually happened. We actually had data, sometimes it didn't always get right next to 17%, but it was very close. In this example here, they talk about tossing a coin, which is a fair coin, what they call it. We know that the theoretical probability of getting heads or tails is 50-50 or 1/2. And they did an experimental probability here where they tossed the coin 10 times, 4 of which was heads and 6 was tails. So the experimental probability of getting a heads was 4 of 10 or 2 over 5, and the experimental probability of getting a tails was 6 of 10 or 3 of 5. And remember that 1/2 equals 50%. Well, 4 over 10, or if you reduce it to 2 over 5, equals 40%. And the 6 of 10, which reduces to 3/5, gave us a 60%. So it wasn't exactly 50% in the statistic, but they do say that the more experiments we do, the closer the probabilities get to the theoretical probability. So for our example with our numbered cubes, we rolled it 20 times. If we were to say roll it 100 times or 500 times, we would get a much closer data. It would be much more accurate, and in many cases we'd be closer to our experimental probability than we would by just rolling 20. They say experimental probability is particularly useful when looking at problems in which involve events and outcomes for which we don't know the theoretical probability. So we use experimental probability to get an approximation. One of the most common used situations for experimental probability is when you're dealing with the lottery. Many times you have the Mega Millions jackpot at an extraordinary amount, so a lot of people buy, but not many people win. So it always seems to be like a very, very small percentage of odds of winning. So you have what it is the number of successes divided by the number of trials. So the number of successes means that that's how many people have won the lottery, and the number of trials is the number of people who actually played. So that's how they determine that, and that's how they're able to get that type of data. Second portion here deals, like we had probability, now we're going to deal with odds. This is also broken up into 2 categories. You got odds in favor, and you have odds against. Odds in favor gives you the ratio of number of favorable outcomes over the number of unfavorable outcomes. So that's a little bit different than probability. In probability, like say for the flipping of the coin, you have 1 chance of success and two times or number of trials. And here, when you talk about odds in favor, you have 1 favorable outcome and you have 1 unfavorable outcome. So if you're trying to get heads, you have the 1 favorable outcome, and if it's tails, that's the unfavorable outcome. Same which talks about odds against. It means that the terms just flip. It's the number of unfavorable outcomes over the number of favorable outcomes. And let's look at this example. It says we have a department store is offering a discount on sunglasses. The table shows the number of discounted sunglasses. You choose a pair at random. Okay. So it's, for example A, it says what is the probability you choose a pair that is polarized? So let's look. I have polarized right here, and it has no specifications on whether or not it is green or brown. So I can get 8 green lenses and also 4 brown lenses. So that becomes 12 over, how many are there total? So we got 8 plus 4 plus 7 plus 9, which is 28. And if I were to reduce this, this would equal 3 over 7. So I have a 3/7 chance of getting polarized lens. For B, they're asking what is the probability that you choose a brown mirror lens. So I have brown and mirror, so that means that I have the mirror ones here, and I also now have the brown. And so I can only get 9 brown mirror lens, and there's 28 possible. And I believe that is in those terms. Yes. So the probability of me getting a brown mirror lens is 9 out of 28. C, they're asking what are the odds in favor of picking green lenses. So odds in favor mean how many. It's the number of favorable outcomes um, over the number of non-favorable outcomes. So I have me picking a green lens. So just green, doesn't matter if it's polarized or mirrored. There are 8 polarized and 7 mirrored, so there's 15 favorable outcomes I could get over 13. So it's what, 15 over 13? So my odds in favor of picking a green one is 15 over 13. And now they ask, what is the odds against picking a green polarized lens? So odds against, again, that's what number of unfavorable outcomes. So let's see, they want to know what the odds against of picking a green polarized lens. So this is the number of green polarized lenses, 8. So the number of unfavorable outcomes would be 7 plus 9 plus 4. So that gives you 20 over 8. And that is using or finding probabilities and odds. Hope this helps. Until next time.